mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen.
For months, the world's biggest telescopes have tracked a mysterious object tearing through our solar system. The news called it just another comet. But the truth? 3I Atlas is breaking the rules. From its backward tail to alien chemistry, 3I Atlas is no ordinary visitor. This is what the news should have told you about the strangest traveler we've ever seen. What the news never told you. When 3I Atlas streaked into the headlines, the story was packaged neatly for the evening news. A strange comet from another star system passes through our solar system. Quick, flashy, and then on to the next story.
Astronomers are trying to gather information about a comet passing Earth, first discovered on July 1st near Jupiter.
But what the news left out was the very thing that makes this object different from anything we've seen before. Atlas isn't just another cosmic ice ball drifting by. It's rewriting the rules of astronomy in real time. For the past several months, the world's most powerful telescopes, Hubble, James Webb, and even specialized satellites like TESS, have been locked onto a single point in the sky, following this alien visitor. Not because it's pretty, but because it's weird. Every time astronomers think they've figured it out, Atlas throws another curveball. The news headlines gave you a comet. Science says this could be something far stranger. Atlas has a tail that points in the wrong direction, a chemical makeup that doesn't exist in our solar system, and a brightness that's switched on long before it should have. To call it a comet is like calling a UFO just another plane. Technically safe, but deeply misleading. This is only the third interstellar object humanity has ever detected. The first, Oumuamua, left us baffled in 2017 when it sped through space like a cigar-shaped enigma. The second, Borisov, acted more or less like a regular comet, only with the twist of being from another star. But Atlas, it's in a league of its own. Brighter, stranger, and far more revealing about the universe than the news bothered to explain. The truth is, this object doesn't just challenge our understanding of comets. It challenges our understanding of the universe itself. How was it formed? Why does it defy the laws of physics we thought were universal? And the question no one on the nightly news dared to ask.
3I Atlas was an interstellar visitor.
Could it be something more than natural? The headlines told you a comet passed by. What they should have told you is that we've stumbled across one of the most mysterious objects ever seen in the sky. And this time, the answers may change how we see our place in the cosmos, an alien visitor from the stars. When astronomers confirmed 3I Atlas wasn't bound to our sun, one fact became unavoidable. This object wasn't born here. It came from the void between the stars, carrying with it the fingerprints of a different solar system. That alone makes it historic. Interstellar objects are vanishingly rare. In fact, before 2017, no human had ever seen one. For centuries, comets and asteroids discovered by backyard observers and giant observatories alike had always been native to our sun's family. Icy leftovers or rocky fragments shaped by the same cosmic recipe. Then, suddenly, Oumuamua arrived. Oumuamua, the first interstellar object ever recorded, entered like a mystery novel dropped into astronomy's lap. It was cigar-shaped, oddly reflective, and it accelerated in ways we couldn't explain. Some said it was an alien probe. Others said a shard of a broken planet. Either way, it came and went so quickly that the debate never ended. Just 2 years later, a second visitor appeared, 2I Borisov. Unlike Oumuamua, Borisov looked almost ordinary. It sprouted a tail, released gases, and behaved like the comets we knew, except its chemical makeup told us it formed around another star. If Oumuamua was the cryptic stranger, Borisov was the relatable cousin who still reminded us that interstellar travel was real. And now comes 3I Atlas, the third. But this one doesn't fit neatly into either box. Unlike Borisov, it doesn't behave like a normal comet. Unlike Oumuamua, it doesn't play the silent enigma. Atlas is loud, bright, active, and doing things no comet has business doing. That's why astronomers didn't treat this as just another visitor. They treated it as the most valuable one yet. Every interstellar object offers a gift, a chance to peer into the chemistry and physics of another solar system without leaving home. But Atlas isn't just a sample, it's a contradiction. Its chemistry, its tail, even its behavior under the sun's light all suggest it comes from a place radically different from ours. A place where the rules we rely on don't necessarily apply. And that's the hook. 3I Atlas isn't only passing through, it's a messenger, carrying secrets from a star older than ours, written into its very structure. The news gave you a comet. In reality, we're looking at a relic of another world, and maybe another way the universe can work. Discovery and the race to observe. On July 1st, 2025, a faint moving dot appeared on the Asteroid Terrestrial Impact Last Alert System, better known as ATLAS. It was designed to spot hazardous space rocks before they get too close to Earth, but this time it caught something much stranger. The system flagged the object, astronomers confirmed it, and just like that, 3I Atlas entered the books as the third interstellar visitor ever found. But here's the twist. It wasn't actually the first time anyone had seen it. Weeks earlier, on May 7th, NASA's Transiting Exoplanet Survey satellite, TESS, had already captured Atlas, drifting silently between Saturn and Jupiter. TESS wasn't looking for comets. It was built to hunt alien planets, so the odd light in its images went unnoticed. Only later, once Atlas was officially discovered, did scientists comb back through the data and realize we had been staring at it all along. This early sighting turned out to be a goldmine. It gave astronomers a head start on calculating Atlas's speed and path, and the numbers told a shocking story. Unlike objects born in our solar system, which orbit the sun in predictable ellipses, Atlas was on a hyperbolic trajectory, a one-way ticket. It was moving so fast that no gravity, not even the sun's, could trap it. To put that speed into perspective, think about the legendary Voyager probes. Launched in the late 1970s, they took nearly 2 years just to reach Jupiter's orbit. Atlas covered that distance in mere months. It was moving at a pace that screamed alien origin. The realization triggered an international scramble. With only a limited window before the object vanished behind the sun, telescopes across the globe and in orbit pivoted toward it. Time on instruments like Hubble and James Webb is planned years in advance, but schedules were ripped up for Atlas. Even Europe's Mars orbiters were called into service for a future flyby. Why the urgency? Because opportunities like this don't come often. In all of human history, only 3 interstellar objects have ever crossed our skies. If scientists missed their chance to study Atlas up close, the universe might not deliver another like it for decades. Maybe centuries. The impossible glow. When astronomers first traced Atlas back to its earliest images, one detail didn't make sense. It was already too bright. At the time of its first detection by TESS, the object was still far beyond Jupiter's orbit, a place where comets are normally nothing more than cold, silent icebergs drifting in the dark. Yet Atlas was glowing like it had already woken up. Here's why that's strange. Typical comets in our solar system are made mostly of frozen water mixed with rock and dust. As they fall inward, the sun's heat begins to boil the ice directly into vapor, a process called sublimation. That's what produces the spectacular fuzzy halo or coma and eventually the tail. But sublimation doesn't kick in until comets get much closer to the sun, usually inside Jupiter's orbit where sunlight is strong enough to warm them. Atlas broke that rule. It was shining brightly, long before it reached that zone. Over a matter of weeks, astronomers watched it get even brighter, as if something in its composition was firing off early. That immediately raised questions. Was it made of more volatile materials like carbon dioxide or carbon monoxide, which can vaporize farther from the sun? Or was something else happening, something we hadn't seen before? To make the puzzle sharper, comparisons to the two earlier interstellar visitors didn't help. Oumuamua never showed a visible coma at all. It stayed oddly clean with no halo of gas or dust. Borisov behaved like a normal comet, but only once it got closer to the sun. Atlas was the opposite. Its activity switched on sooner than physics seemed to allow. For astronomers, this was the first big red flag. An object from another star system should follow the same rules as comets here, at least in broad strokes. But Atlas was glowing early, brightening fast, and ignoring the thresholds that define how icy bodies usually behave. The news might have dismissed it as just a comet lighting up. But to scientists, the impossible brightness was a message. Atlas wasn't made from the same recipe as anything in our neighborhood. It was carrying the chemistry of another world, written in light. The tale that broke the rules. Every comet has a signature, the glowing halo of gas and dust, and the long tail stretching away from the sun. It's one of the most predictable behaviors in astronomy, a law written into physics itself. The sun radiates not just light and heat, but a constant flow of charged particles called the solar wind. That wind always pushes a comet's tail outward, away from the sun, no matter what direction the comet is traveling. But 3I Atlas didn't follow the script. When astronomers zoomed in on its coma in late summer, they noticed the tail wasn't trailing politely behind it. Instead, it was bending in the wrong direction, pointed toward the sun. Imagine a dog leaning its head out of a car window, and instead of its ears blowing backward, they flap forward against the wind. That's how bizarre this looked. This discovery sent ripples through the astronomy community. Because if a comet's tail doesn't respond to solar wind the way every other comet does, then either our understanding of the object is wrong or our understanding of the solar wind is incomplete. Neither option is comfortable. So what could explain it? One possibility is that Atlas is producing jets of gas strong enough to counteract the solar wind, forcing its tail in an unusual direction. But the energy required for that is staggering, and no other comet has shown such a defiance of physics. Another explanation might involve magnetic fields interacting with the gases being released. Yet again, nothing in our catalog of comets matches the behavior we're seeing here. This wasn't the first interstellar oddity to challenge expectations. Oumuamua refused to show a tail at all, and its unexplained acceleration is still debated today. But Atlas's tail wasn't just absent, it was actively rebelling. Where Oumuamua was silent, Atlas was loud, practically waving a cosmic flag saying, "Pay attention." The public barely heard about this. News outlets reduced it to a line about strange tail behavior, with no context about how groundbreaking it was. But for astronomers, this was the moment Atlas crossed from curious comet to full-blown cosmic riddle. Because if a comet can shine too early and bend its tail toward the sun, what else might it do? What other rules might it break? Atlas wasn't just glowing in the dark anymore. It was rewriting one of astronomy's most reliable signatures and daring us to follow the clues. What the world's telescopes saw. Once 3I Atlas proved it wasn't following the usual playbook, the world's observatories went into overdrive. Time on instruments like Hubble and James Webb is scheduled years in advance, often after fierce competition. Yet, within days, plans were scrapped and pointed skyward toward a single streak of light. That decision alone tells you how seriously the scientific community was taking this visitor. The Hubble Space Telescope was one of the first to lock on. Its sharp vision in visible light gave astronomers a detailed view of the coma, the cloud of gas and dust surrounding the object. Hubble confirmed that Atlas wasn't just bright, It was strangely bright. The size of the halo dwarfed early predictions, stretching hundreds of thousands of miles across. Then came the James Webb Space Telescope, the crown jewel of modern astronomy. Webb's infrared eyes peeled deeper, revealing the chemical composition of that massive cloud. Instead of the expected water vapor, Webb found overwhelming amounts of carbon dioxide. The ratio, 16 parts CO2 for every 1 part H2O, was unlike anything seen in our solar system. For scientists, it was the first smoking gun that Atlas had been born under alien conditions. Europe also joined the effort. The Very Large Telescope, VLT in Chile, despite its unassuming name, delivered a shock. It detected nickel metal in the gas cloud, but no trace of iron. That broke another cosmic rule. Iron and nickel are partners forged in supernovae, and they seldom travel alone. Yet here was Atlas, flaunting nickel without its twin, forcing astronomers to consider possibilities that ranged from exotic star systems to artificial processes. Other instruments filled in the gaps. TESS, the exoplanet hunter that accidentally captured Atlas before anyone knew what it was pulled back into the mission. It tracked changes in brightness with extreme precision, helping scientists build a timeline of the object's behavior. Meanwhile, the upcoming SphereX mission, designed to map the entire sky in infrared, was accelerated to grab a few snapshots, contributing data about how sunlight scattered off Atlas's vast coma. What all these observations revealed was a layered picture, a visitor with alien chemistry, puzzling physics, and an evolving structure that refused to sit still. Each telescope added a piece of the puzzle, but together they didn't form a neat image. Instead, they made the mystery deeper. The world's most advanced eyes had turned toward Atlas, and yet the more they saw, the less sense it made. Alien chemistry in the coma. When James Webb analyzed the light from 3I Atlas, the results startled scientists. Instead of a familiar mix dominated by water vapor, the coma, that ghostly halo surrounding the core, was overflowing with carbon dioxide. The ratio of CO2 to H2O wasn't just unusual, it was staggering, 16:1. To put that into perspective, comets from our solar system are mostly water ice. Yes, they carry carbon dioxide and carbon monoxide, but only in small amounts. Here, the balance was completely inverted. It was as if the cosmic cookbook had been written in reverse. The chemistry screamed, "This object is not from here." Even more astonishing was the scale of the coma. Observations suggested it ballooned out to nearly 186,000 miles across, almost half the diameter of the Sun. That meant a solid body, perhaps just a few dozen miles wide, was wrapped in an atmosphere the size of a star. It made Atlas appear brighter and more active than most comets, many times its size. At first, estimates of the nucleus, the rocky, icy heart at the center, hovered around 11 miles across. But with so much carbon dioxide being vented, astronomers had to revise those numbers. Some now suggest the core could be as wide as 30 miles or more, still modest compared to the giants of our solar system, but enormous given the energy pouring out of it. What does such an extreme CO2 content mean? One theory is that Atlas formed in a planetary nursery very different from our own. Perhaps its parent system was colder, richer in carbon dioxide ice, and poorer in water. Another possibility is that it was once part of a planet or moon that experienced processes unlike anything Earth has seen. For scientists, the coma was more than a glowing cloud. It was a chemical fingerprint of another solar system. By studying its spectrum, they could read the recipe of alien worlds billions of years older than our Sun. The public was told Atlas was just a comet. But no ordinary comet carries a shroud of gas hundreds of thousands of miles wide, built almost entirely of the wrong ingredients. That's why researchers weren't shrugging. They were staring at evidence that planets and stars elsewhere in the galaxy may operate by rules we've barely begun to imagine. The nickel without iron puzzle. As if the chemistry of 3I Atlas wasn't strange enough, another discovery pushed it into even more puzzling territory. Using the Very Large Telescope in Chile, astronomers scanned the coma, that massive carbon dioxide cloud billowing around the object, and detected a familiar metal, nickel. That alone wouldn't be surprising. But what they didn't find was even more important. There was no trace of iron. To most people, that might sound like a small detail. To astronomers, it was a shockwave. In the universe, nickel and iron are cosmic twins. They're created together in the fiery deaths of stars, the explosions we call supernovae. These metals are forged side by side and blasted out into space in equal measure, later becoming the building blocks of planets, asteroids, and comets. That's why nearly every rock we've studied in the solar system carries both. You don't see one without the other, except, apparently, in Atlas. The finding was baffling because it broke a rule that seemed unbreakable. If nickel is there, iron should be too. Yet observation after observation confirmed the absence. Scientists ran the numbers again and again, checking for errors, but the data didn't change. Atlas was venting nickel all by itself. So how could this happen? There are a few theories. One possibility is that Atlas formed in a star system with exotic conditions where iron condensed differently or sank into the core of a parent planet before fragments like Atlas were thrown into space. Another is that some unknown physical process separated the metals along their journey. Both ideas are difficult to prove, but then comes the more controversial thought, the one whispered more than published. On Earth, the only place where we ever find nickel separated cleanly from iron is in human industry. We refine metals for construction, for machines, for technology. Could it be possible that what we're seeing in Atlas isn't natural at all? Most scientists stop short of calling it alien engineering. That's a leap too far without evidence. But the fact remains. Atlas breaks a pattern written into the universe itself. Either it carries the story of a solar system with rules very different from our own, or it's something more deliberate. The news headlines never mention this. But in the labs and observatories, the nickel puzzle left astronomers with goosebumps. Atlas wasn't just rewriting chemistry textbooks, it was making some wonder if we were staring at a fingerprint of intelligence. Blackout, Mars, and Jupiter. The clock is ticking. Every discovery about 3I Atlas carried a catch. Time was running out. Objects from interstellar space don't hang around. They streak in, offer a brief glimpse of their secrets, and vanish forever. Astronomers knew they had just a few windows to study Atlas, and each one mattered. The first major deadline was the solar blackout window. Starting in late October 2025, Atlas would line up with the Sun from Earth's perspective. For about 6 weeks, its faint glow would be completely drowned in solar glare. No ground telescope, no space telescope, not even the mighty James Webb could separate it from the Sun's blinding light. That blackout came at the worst possible time, right when Atlas would be at its closest approach to the Sun, the very moment when comets are most active. In other words, the most revealing phase of its journey would unfold while we were blind. Before that happened, astronomers had one golden chance. In early October, Atlas would swing past Mars, coming within about 17 million miles of the red planet. That's still a vast gulf by human standards, but close enough for orbiters already circling Mars to take a look. The European Space Agency lined up both the Mars Express and the ExoMars Trace gas orbiter to photograph Atlas with high-resolution cameras. Nobody expected crystal-clear portraits, but even a faint outline of its nucleus against the coma could tell us something critical: the shape of the solid body at its core. Was it spherical, jagged, or elongated like Oumuamua? That snapshot could answer questions that theories alone couldn't settle. And then there's the long game, March 16th, 2026. On that date, Atlas will fly past Jupiter at a distance of about 33 million miles. It's not a close shave, but there's a twist. NASA's aging Juno spacecraft is still in orbit around Jupiter. Its mission was scheduled to end in late 2025 with a controlled plunge into the giant planet. But with Atlas on approach, some scientists have suggested one last act for Juno: redirect it for an intercept, capturing images and data no telescope from Earth could rival. In a cosmic sense, these opportunities are fleeting. Atlas will never return. Once it slingshots past Jupiter, it's gone. Back into interstellar space, beyond the reach of our instruments, maybe forever. That's why every observation counts. For astronomers, Atlas isn't just an object to study, it's a deadline written in the stars. The meaning of 3I Atlas. By now, one thing is clear. 3I Atlas is not just another comet. From the moment it appeared, it challenged nearly every assumption astronomers held about how icy bodies behave, what they're made of, and how they respond to the sun. But beyond the data, the chemistry, and the physics, Atlas raises a bigger question. What does it mean for us? For scientists, Atlas is a time capsule. It isn't just drifting rock and ice, it's a messenger from another star system. Locked inside its chemistry is the story of how alien worlds formed, what elements dominated, and what rules shaped them. Studying Atlas gives us a rare window into solar systems that may be older, colder, or more volatile than our own. It's like opening a geology textbook written in another language, one we're only just learning to translate. For humanity, though, Atlas is more than science. It's a reminder of scale. Every so often, an object slips into our neighborhood from the deep galactic ocean, stays briefly, and then races back into the dark. Each one forces us to ask whether we're alone, not because they're proven alien spacecraft, but because their strangeness keeps that door wide open. Oumuamua sparked the debate. Borisov showed us the familiar. Atlas. It has kept the conversation alive, with evidence no one can easily dismiss. And here's the part the news rarely admits. Science doesn't always have neat answers. In fact, the more we learn, the stranger things become. Atlas might never fully reveal what it is. Even with all our telescopes, even with Mars orbiters, and possibly Juno's last look, some mysteries may remain locked inside it forever. That uncertainty is uncomfortable, but it's also what makes discoveries like this so powerful. Because the truth is, Atlas reminds us that the universe is not finished surprising us. Beyond our sun, there are billions of stars and billions of planetary systems, each shaping matter in ways we've never imagined. Objects like Atlas are proof that we're just beginning to scratch the surface of cosmic diversity. The news gave you a headline, another comet. What they should have told you is that we've glimpsed a piece of another world, racing past ours at interstellar speed. And in that brief encounter lies both a mystery and a message. The cosmos is far stranger and far richer than we ever give it credit for. What do you think this strange visitor really is? A comet, a cosmic accident, or something we've never imagined? Drop your take in the comments, hit like if you enjoyed the ride, share it with a space fan friend, and don't forget to subscribe for more mysteries waiting in the stars.